Mr. German, good morning, ladies and gentlemen. I would like to welcome you to my presentation, in which I'm going to speak about the problems of migratory fish. I would like to start my presentation with a quote. "No human being, however great or powerful, was ever so free as a fish." And he's repeating the quote in German. This is a quote of John Ruskin, a British author, dated the 19th century. And I'm asking myself whether he would repeat this if he knew about the problems of modern fish. Here I'm listing the fish that are extinct in Switzerland, 8 different types, and also a lamprey. And those that are in grey are the true migratory fish that migrate between freshwater and saltwater, and life was quite difficult for that fish, and they've got considerable problems in repopulating the rivers and the streams. I'm going to focus on 2 fish, the Atlantic salmon, that was already mentioned by Mr. German, and the other migratory fish, which is not always in the foreground, but it still exists. It's not extinct yet. That is the eel that is doing fantastic journeys. Here you see some statistics and problems of the salmon. Here you see the catch of salmon until 1932. And then another power plant was built in Camps, and that was it for salmon. Camps was destroyed in World War II, and therefore the figures improved again, but at the end of World War II, that was it. In addition, the other true migrant fish that migrate between seawater and freshwater. The eel, for example, is assessed as critically endangered by IUCN. In Switzerland, it is endangered, but the big problem is very complex. But we must say that power plants are a considerable problem for eel. But on the other hand, silver eel is sold commercially, and therefore they don't come back into the rivers and streams. Here you see the different power plants between Iffezheim and Schaffhausen, 21 power plants. And here the Herculean task is to open this river for the salmon, but also for the other migratory fish. The eel is relatively big, and therefore it should also be taken into account. Let's come back to the Swiss river bodies. We've got 65,000 kilometers in Switzerland, with more than 100,000 artificial structures higher than 50 centimeters. And there are hundreds of thousands of small barriers. The average distance is round about only 645 meters without any barriers. And of course, they have got a clear effect on the fish. Not every fish, such as the trout, is a master in jumping, and the sea trout can jump 2 or 3 meters without any problems, but most fish can't. So they fail at these barriers, at these weirs, at these pipes, culverizations, etc. Of course, it is very often believed that with fish facilities this could be overcome, but downstream migration is still very difficult. Then we have got the problem that tributaries don't provide any refuge depending on the water levels or the water temperatures. I would like to come back briefly to the smaller barriers. They have an effect as well on smaller fish, such as the bullhead. the bullhead can overcome only barriers of 25 centimeters, and that's it. And we examined that, and we wanted to know whether they migrate or not. We were told that bullhead, very often here, that bullhead don't migrate. But as a matter of fact, we used these tags in order to monitor them, and we found that they do migrate also, but over smaller distances. And here you see the results, 63 that were tagged. So the mean distance was 175 meters. That is much more than we can read in literature. And some fish even migrated over slightly larger distances. So even smaller barriers have a great effect on smaller fish. And now hydropower plants. We have got 579 power plants that are considered to be larger power plants, and more than 1,000 that are smaller hydropower plants. And of course they have an effect. Deficits have been listed by now. The cantons did a great job. And they were able to prove that 1,852 barriers exist caused by power plants. There are 706 power plants where upstream fish facilities would be required, but only 65% have got an upstream fish facility. And those who do are not always efficient. Only 36% are considered to be fully functional. So we have to improve that situation until 2030 in accordance with the law. Very briefly, I would like to show you why fish migrate and how you could establish different categories. There are five categories: feeding migration, migration in order to seek refuge, spawning migration, compensation migration, and colonization. And I'm going to explain each of them briefly. But perhaps we have to introduce a concept which became very important for ecology in recent years, because we're not because in a population you might only have partial migration. So there is migration and non-migrating individuals. A population can consist of migrating and resident individuals. And the size between migrant and resident individuals differs. Usually those that migrate are larger, and partial migration is very frequent among fish. It has an effect on the structure of the feed, and it also has some trophic effects. Here you see migrating animals. They bring nutrients, energy, but also parasites into the population. But here we have the resident community that profit from migrating animals, primary producers, primary consumers, and secondary consumers in the resident community, in the resident population. And this is what we call the trophical effects. And these ecosystems are more stable if there are also some migrant fish. So let's continue with the 5 types of migrations. For feed. Why do they migrate? Where they want to grow faster. This is true in particular for smolts, in particular in spring. They migrate downstream, but it also happens with sea trout. Here you see 2 juvenile salmons. We've got salmons in Switzerland. We stock them. There is a project in the Murraybach. Merlinbach. This is a smolt, and it is ready to migrate, and it's relatively big. As a matter of fact, it will leave for the sea quite soon, but this one is not ready yet. It's smaller, and as a matter of fact, it will stay in the area for another year. And I will show you how this migration can be made visible. So smolt migrates between January and the end of April when they are a year or 2 years old, and the sea trouts do it in a very similar way. In spring, they migrate to the sea, or brown trout, they migrate also in spring. So this is some statistics on smolts. Here we cover November to May 2014. In blue, you see the discharge of the stream, the temperature, and in black, the number of migrating individuals. All of them were given p-tags, and thus we can follow them very precisely. And you'll see a picture in a minute. Here you see that migration is always related with a higher discharge. But here as well, there's only a slightly higher discharge. It was interesting for us that they've got such a large window that they start already in November or December. So that was something that was totally unknown. But it will also be presented by Mr. Kunz, who did his master's thesis on it. Here you see the mouth. Here you see our solar-powered equipment with the reader, etc. You see the antenna, the pit-tag antenna, and no salmon, no smolt will manage to pass the antenna without being registered. So this is the system. With these modern methods, you can make migration nicely visible, but there's also migration of subadult and adult fish, also for feeding reasons. Usually in the summer, it's a bit shorter, usually 3 kilometers roundabout or even less. That would be common days, common bream, rod or chops. Okay, next class is seeking refuge. Why do fish seek refuge? Well, they want to avoid stress. Under unfavorable conditions, such as floods or temperatures, they move or migrate to the winter habitats, such as the barbels or the nazies. They also look for tributaries in case of floods, or common minnows. Whenever there is hydro peaking, they seek tributaries, and when the level goes down, they come back into the mainstream. This is another picture. Here you see the total number of upstream migration just for barbels, and you see that this fish pass is used actively in October and November, and we interpret that as winter migration into the sea. So this is a large number of individuals that migrate in that time period. Then spawning migration, there would be a return to the reproduction areas, very often longitudinal upstream migrations in a specific window. This is done in particular by fish spawning into gravel, such as salmon, or the sea trout in the Alpenrhein. And that is, for the latter, it is a distance of 125 kilometers roundabout. But also in the Rhine tour system, we found relatively large distances. Here, the sea trout from Lake Constance. Since the year 2000, there's been a fish facility right here, and thus can migrate up to 25 kilometers. This is an enormous performance, but I'm afraid we still have problems with downstream migration here. But the eel is also migrating more than 5,000 kilometers very often. The silver eel want to go back to the spawning area. And of course, they are protected by a European ordinance. European ordinance, but there are considerable problems because of the turbines. The pressure is high. It's not only the power plants. Yes, the power plants are a considerable problem because these large eels, they are very big, as a matter of fact, sometimes more than a meter long. And in order to protect them, the gaps for the screens should be smaller than 15 millimeters. And if we've got 20 millimeters, the eels would slip through the rakes or screens. Is that a utopia, these 15 millimeters? No, it isn't. Here, this is Wielstedt at Kinzig, at the river Kinzig. It is 10 millimeters. It's a vertical screen, which you can't see because it's underwater. And what you see here is the drift cleaner, because you need to clean such a screen or rack. This is feasible in particular for smaller power plants, but there are eels and other smaller fish that you can protect. Then spawning migration all the way to Thurgau. Some fish migrate up to 29 kilometers in downstream migration, so that is considerable. Another fish that I would like to mention is whitefish. We've got migrating whitefish in the Alps region. We've got some migrating from Lake Constance all the way up to Buchs or Elhorn. And as a matter of fact, this is where they're stopped. But this is a fantastic performance of fish, although it is not expected. Graylings would also migrate. This is something that we were not too well informed about, and we didn't believe that they could perform that well. In Belgium, they have measured a maximum distance of 5 kilometers, but in Germany there was a study proving 11 kilometers and even more. This is not spawning migration, but another study from Norway shows that 37% of the graylings have a home range of more than 10 kilometers. So this is true for the rivers Lagen and Glomma. And we do know that this happens also in Switzerland. And as a matter of fact, when you read my presentation on the web, you can read that for yourself, because that is information for Switzerland. There are other fish, such as days, that migrate for reproduction. In the UK, it was proven, and also in Germany and in Reuss and in the river the Rhone, we were able to prove between 3.5 and 23 kilometers of chops. But small fish would also migrate for spawning purposes. We know from minnows that they could also migrate upstream up to 1,000 kilometers. But there is not only longitudinal migration, but here this is a wetland area. So fish such as the common bream would also migrate to such areas, which has also been described quite nicely. Migration for compensation, drifts because of floods or other translocations. Here you see the River Nid in the UK, and you see a barbel, and that is tagged. And whenever there is a flood, it is carried further downstream, but then it migrates back. So fish want to go back to their original habitats when they are drifted, and it's very important for them to permit this. And then colonization or recolonization of scouting, so to speak, colonization of formerly inhabited areas which had unfavorable conditions, and this kind of recolonization takes a long time. Sometimes it takes very many years. This could be sections that were revitalized or restored, or migration to sections of rivers that are accessible again. Very often, as I've said before, it takes years, but fish go for it. Then we would have to clarify when fish would migrate. Well, upstream migration takes place during the entire year, but there is a main time period between March and October for salmonids and burbot. We have to say, however, that they would also migrate in the winter time. Downstream migration takes place for the entire year. This is true for salmonids, eels in fall, but also in winter. But adult cyprinids migrate primarily between September and December. The stimulus for migration, we've seen some factors. It is either more water, temperature, longer days, or moon phases. Very often it is not a single factor that triggers migration, but several factors that are of relevance. Last but not least, I would like to come back to a number of applied aspects of fish migrations. All of these effects are caused by man. Bridges over the river, culvertization, large and smaller barriers to stabilize the rivers, power plants with upstream and downstream migration problems, hydropeaking. All of these problems do exist, and thus we have to ensure that we support fish. Also some mitigation measures. This is an example from the United States. I didn't find a picture from Switzerland, therefore I stole it in the US, so to speak. This is the original, and here the solution that is found. Then rock ramp fishways, barriers should be removed. And rock ramp, Simona Damani will talk about rock ramp fishways. This is to remove barriers such as this one here and then build the rock ramps. Power plants, we have to ensure that upward migration is possible via a fish ladder, but in the future we also have to ensure downstream migration. If we take a look at such a ladder, there are a number of technical questions that have to be answered. Where do we position it? The flow conditions, what are the conditions to enter this ladder so that the fish would actually find it? But also upstream migration, what is the technical assessment? Mr. Heimel will come back to these technical questions, and I'm very much looking forward to it. But there are a number of biological questions that we would have to discuss much more intensively in the future. The role of turbulences, for example. We do know that fish avoid turbulences, but they can also deal with turbulences. This was not sufficiently taken into account. Then the performance of the fish, fatigue has to be taken into account, behavior because of the flow, and problems with predators. Very often predators are so to speak, sitting next to the fish ladders, and that is an additional risk that has to be taken into account. And then, so far, we have had very few fish facilities for downstream migration. This is a horizontal screen. And in 2 or 3 years, we might know whether the situation has improved or not. This is the power plant Rüchlig, and there's also a downstream migration facility. And this is a link to tomorrow's presentation. We're talking about major rivers where the situation is totally different than in VAW and Eawag. We've done a study to examine such channels, and this is something that we're going to present tomorrow. Well, Yes, we do have a number of problems with fish migration, but we also have considerable knowledge by now, which means that we have to employ the most modern technology. By way of that modern technology, we can document the situation and barriers and the behavior of the fish. We can see and recognize the migratory pattern over time and space. And only if we are aware of this information, we can provide the very best protection to ensure the survival of the highest number of species. So I do hope that we will use more of the tags in the future in order to protect fish. And I would like to thank you for your time.